All right, we're going to go on this incredible high-speed journey. We're going to follow a single database query from the very instant you click a button to the moment you get your answer. It's a trip that happens millions of times a second, all over the world, and it's pretty much the hidden engine of our digital lives.
I mean, think about it. You search for a product, a photo, maybe a friend, and boom, in less than a blink, the right info just appears. That's not magic. It's an incredibly sophisticated process. And in this explainer, we're pulling back the curtain to see exactly how it all works.
So, here's the roadmap for our query's little adventure. We'll start right at the beginning. Watch how the database decodes what you're asking, then see how it maps out a plan, searches for the fastest possible route, and finally, why this whole split-second process is so crucial for the tech we use every day.
Okay, so this is where our journey kicks off. You've asked a question, and the database has received it. But it doesn't just jump into action. Its first job is to figure out what you're actually asking for. And this, right here, is the very start of what's called query processing.
So, the key thing to get here is that we write queries in languages like SQL, right? They're made for us, for humans. Query processing, that's the essential translation step. It's all about turning our human-readable request into a set of precise, low-level instructions the machine can actually follow.
And that whole translation process, it happens in 6 main steps. The database checks our grammar, then it checks our meaning, then it figures out the smartest way to get the data, generates a plan, runs it, and finally sends back our answer. So, let's walk through this, step by step.
So before a single piece of data is touched, the database has to do its homework. You can think of it like a super careful librarian checking your request form. First, to make sure you filled it out right, and second, to make sure the books you're asking for are even on the shelves.
Okay, so this check has 2 parts. First up, you've got parsing and validation. Basically, is the SQL command written correctly? Are all the keywords and commas where they should be? Then you've got semantic analysis. The grammar might be perfect, but do the tables and columns you mentioned, like users or purchase_history, actually exist in this database? Only when both checks pass can the query move on. Once the database understands what you want, it needs a plan. It's not just going to start grabbing data all willy-nilly. Instead, it builds an internal blueprint, a flowchart really, for how it's going to get you that data in the most efficient way possible.
And that blueprint, we call that a query tree. It's a visual, hierarchical map of all the operations that need to happen. Imagine them like a real tree. The data sources are down at the bottom, like the roots, and your final result, that's at the very top.
All right, let's take a look at an example here. A standard SQL query gets broken down visually. The from clause, that points to the base tables, employee and work on, which become the roots of our tree. The where clause creates these filtering branches, and the select clause, that determines the final result you get at the top. It's a perfect map of the query's logic.
So why bother with all this? Well, it's for 2 big reasons. First, it helps developers actually see what the database is doing under the hood. But the real reason, the game changer, is query optimization. This tree structure is what allows the database to look at its own plan and rewrite it for maximum speed.
This is where the magic really happens. You see, that first query tree is just a direct, literal translation of what we asked for. But now, the database's brain, the query optimizer, steps in. Its one and only job is to find the fastest, most efficient path to get you the exact same result.
And its main goal is simple but super important. The primary goal of query optimization is to minimize the execution time and resource consumption. It's not just about being fast, it's about being smart. How can the database get the answer using the least amount of memory, the fewest disk reads, and the lowest CPU usage? That is the name of the game.
And listen, the benefits here are massive. For businesses, this means lower costs, right? Because they can do more with the same machines. It means the system can actually scale up as data piles on. And for you and me, it means faster apps and a way better experience. This is not just some nice-to-have feature, it's absolutely crucial.
So how does the optimizer choose the best path? Well, it's got 2 main strategies it can use. One is based on some simple rules of thumb, and the other is based on some pretty detailed cost math. Let's see how they stack up.
All right, so first you've got heuristic optimization. This is the simple rules of thumb approach. It uses general rules that just, well, they usually work pretty well. Then there's cost-based optimization, which is way more sophisticated. It uses stats about your data, like how many rows are in a table, to estimate the cost of different plans, and then it just picks the cheapest one. The reality is, most modern databases use a mix of both.
Okay, to really get this, let's watch a simple heuristic rule completely change the game for a query plan. This is a perfect example of working smarter, not harder.
So here's our before shot. The initial plan's first step is to join the student and marks tables, basically mashing them together into one giant table. Now, if these tables have millions of rows, this is a huge, slow operation, and only after all that heavy lifting does it filter down to the tiny piece of data we actually wanted. But now the optimizer steps in with a classic rule of thumb. Seriously, one of the most important rules in database theory. It's simple. Do your filtering first. Shrink the amount of data you have to deal with as early as you possibly can.
And boom, here's the after. Just look at how that tree has been totally rearranged. The optimizer pushed the filtering operations way down. So now it finds the specific student and the specific subject first, and then it joins those two tiny results together. You get the exact same answer, but it's just exponentially faster. Okay, so we've seen the nuts and bolts, right? The query trees, the optimization roles. Now let's pull back and connect this to our everyday digital lives.
That whole journey we just walked through, parsing, validating, building a tree, optimizing it, and then running the plan, all of that happens in less than a blink of an eye. This process is the invisible engine behind every search, every social media feed, and every online purchase. The speed of the internet we use every single day, it's literally built on this foundation.
So, the next time you click something and get that instant result, you'll know about the silent, lightning-fast journey happening behind the curtain, a journey of your question being understood, planned, and optimized. It makes you wonder, what other invisible, elegant processes are powering the rest of our digital world, just waiting to be discovered?